Hello there, this is Alana Tucky, and I've received a question about how to do this problem from the homework, which is 12.1, number 23. Okay, so we have a school social worker wants to determine if the grade distribution of homeschooled children is different in her district than nationally. A National Statistical Center provided her with the data in the first table below, which represent the relative frequency of homeschooled children by grade level, and then she obtains a sample of 30 homeschooled children within her district that yields the data in the second table below. Complete parts A and B below. All right, so I'm going to view an example, but it'll work very similarly to the problem. All right, so we have our relative frequencies here, and we have our, so this part over on the left, that's the national averages, kind of, the national proportions. And then over on the right is the frequency from her actual data gathering. So notice that these are pretty low counts, and when we have low sample sizes like this, we'll get low counts, and it says basically to start grouping together the cells. So we're going to combine the cells in the first three categories. So 8 and 6 you're going to combine to make 14, and then 4 through 8 you're going to combine to make 9, and then 9 through 12 you're going to leave as 2. All right, so let me just bring up StatCrunch. That's the best way to put this. Hold on. Here it is. Okay, so I went into StatCrunch, I logged in, and here it is. Okay, so we are observing in real life from her actual data 8 and 6, sorry, 8 and 6, that's 14. Let's see, 4 and 5, that's 9, and then 2 for the last group. And the relative frequency, now we're going to have to add those two. So 0.084 and 0.285. That would be 9, 6, 0.3, and then 6, 9. I think I'm doing that right. Maybe I'm wrong. I think it's 379. Let me pull up a computer. Hold on one second. Oops, I'm in a calculator. There it is. Okay, I was right. 0.369. All right, it's been a long day. All right, 0.369. And then the next two, let's see, 8 carry the 1, 8, and then 3. So 0.388. Oopsie. There you go. And 0.243 over here. Okay, so now we have those values. Now they want us to figure out the expected value, if I'm not mistaken. So first, see, 388, I was right, 369, 243. There's those values, and there's the frequencies. Okay, so now we need to figure out the expected values for another column. And what you do for that is you figure out how many people that she asked altogether, which is the sum of that middle column, which was, here's StatCrunch, so 14 and 9 and 25. So together that makes 25 total, right? So 14, 9, and 2, that makes 25 for the total. So what I'm going to do here is I'm going to find the expected frequencies. You can use a calculator. Honestly, it's faster with Excel, to be quite frank. So let me grab Excel. Excel is so quick for stuff like this. Or you could use a calculator. I mean, either way. So you take 0.369, 0.388, 0.243, and then you have your observed, which was, you don't even need that. All you want is to take each of these values and multiply it by 25, because that's your total. So 0.388 times 25 is 9.7, 0.243 times 25 is 6.075, and so on. You could find these values with a calculator as well. So 9.225, 9.07, 6. What was it? 075. And that was 9.7. That was my fault. There we go. All right, so there's the expected frequencies. So you multiply your total for your observed, which was 25, times each of your relative frequencies. Beautiful. Okay, then we want to run the test, if I'm not mistaken. So let me go back to the problem here. All right, so we find the, see there, the expected frequencies at the bottom, same as what we just found. And now we actually want to run the test. So basically, your null hypothesis is always, that the random variable follows a distribution that was given, and then your alternative to that is that it does not follow that distribution. Then you go to stat, goodness of fit. You want to do the chi-square test. We don't do the normality test. And then you say your observed is in your observed column. Your expected, you actually can pick either one, your relative frequency or your expected frequencies. Either one should work. I'll pick relative frequency for the heck of it. And then I click compute. And there it is. P-value is 0.0722. So let's see if that matches up with what they give. 0.072 right there down at the bottom. So that's perfect. So that's how to run the chi-square test for goodness of fit for this data. So you had to first mush the data together into shorter columns, and then you could run the chi-square test from that. Just to show you on a side note, you actually can run the chi-square test from either one. So if you say observed, last time I did relative frequency, so this time I'll do the expected frequency. And see, come up with the same answer, 0.0722. Now, if you're on a calculator, just real quick, you'd go Stat, Edit, clear any old data you have. And you can type in your observed values, which were, hold on, I'm going to make this smaller so I can see what I'm doing here. Let's see, it was, oh, hey, come here. 14, 9, and 2. And then you could type your expected. So 9.225, 9.7, 6.075. So you get those in there. And then you go to Stat, to the right to Tests. And then down at the bottom, there's the chi-square GOF, Goodness of Fit test. Now, only people with a TI-84 can do this, but there you have it. Our observed was in L1, our expected was in L2. Our degrees of freedom is only 2 because it's the number of categories you have minus 1, and we only had 3 categories. Then you go down to Calculate, Enter. And there it is, 0.0722 for your p-value, just like it was when you did it with StatCrunch. All right, I hope that helps. I'll see you back here for more videos.